Hey folks, and welcome back to Advent of Code. Today is now day number 10, which reminds me I should probably update my Twitch settings. Sorry for those of you who are expecting day 9, this is actually day 10. We are going to be doing this problem as soon as it locks in 3 minutes. I just need to go and update the stream info right here, and we'll be in business. Let's see. So, yesterday was a pretty easy problem. It didn't actually use the virtual machine. So we might use the virtual machine again, we might not. Hey, Epsilon, how are you? So, fortunately, I have my stuff set up a little bit. Hey, Eric, yay, hug-ups to you. Thank you very much for fixing the servers. I read your retrospective, it was really great. I'm glad AWS was super helpful to you all. I found them pretty helpful as well. Cool. Well, I'll send people your way, Epsilon, if I finish before you. Just let me know. Very retro, much spective. Wow, says Eric. Awesome. Yeah, good luck to everyone who is doing Advent of Code. And I look forward to seeing what your solutions look like. What language are you doing, Epsilon? Not sure Epsilon is responding yet to what language they are using. Perl 5. Oh my god, Perl. Okay. That is definitely Eric's jam. It is not my jam, that's for sure. It is definitely not my thing to do Perl, that's for sure. Cool. So the puzzle unlocks in about 1:50. I'm pretty pumped. A9 was hinting very, very, very heavily about the little gaps here, which makes me think that we might be taking a boat the slow way back and working our way back this way if things go not so well on the tropical island. Eric says, not just my GM, that's my entire refrigerator. That's fair, that's fair. Awesome. Well, let's, get a drink of water, and we'll get started with the puzzle in about a minute. So we'll see what we get. But I am suspecting that the algorithms bit will start getting featured a little bit more. We might actually have to do a search for once. It'll be exciting. So yeah, we'll just, see what it looks like. Cool. I'm ready to go here. Oh, I made the classic mistake again. There we go. All right. Well, fingers crossed. I suspect the servers will work just fine once the puzzle unlocks, now that it's been debugged a little bit. But if not, we'll find out. All right, what have we here today? Eric, are we hacking the airplane even further? Eric, why are we doing this? Why are we hacking the airplane to avert tropical storm disaster? Okay, that seems totally reasonable. All right. So we just need to download a list of number of volts. Yeah, it's true. We all wish we could take a vacation right now. All right. I have my input. It is a complete input this time. So let's, indeed, we have to parse a bunch of numbers. So let's do the simple thing. Let's just make sure that we know what the highest is. And we need to step everything up slowly. Okay, that makes sense. So I suspect we just need to sort them in order, do I not? 1, 2, or 3. 5, 6, or 7, but I have to pick 5, 6, then 7. Wait, why is this not just literally picking... why is this not literally just sorting? This feels like this is literally just sorting, except for then adding 3. I don't see how this is not just literally sorting. Okay, fine. So we're going to need the sort library, and we're going to need to remember how the sort works. All right. No, I just literally want to sort a bunch of integers. That is literally all I want to do. Great. Okay. Make length of split. All right, fair enough. I was looking for a trap, but there was really not a trap. We do that, and then we're going to just run its voltages. Okay. I think I just really overthought this, but I hope the second part will get harder. We'll figure that out as we go along. Okay. Simple enough. 1 and 3. And then the last time for good measure, because we are using my highest one at the end. I think that should work. That's correct. Wait, how did I get rank 256? What the fuck? Did everyone else overthink this too? I guess everyone did. I did not expect to place this highly. Okay. Wonderful. How many different ways can I arrange them? Okay, this is much more like what I was expecting to see. What is the total number of distinct ways I can arrange the adapters to connect the charging outlet to my device? Wonderful. All right. So now this is going to rely on the technique that I described in order to calculate the number of valid ways, because you start from the bottom and you work your way up. So the way we're going to work this is all right. So we're going to do it this way. So as we go along, we only need to consider the number of ways to reach a thing based off of how many things that are ahead of it. So, for instance, I know for a fact that ways of voltages minus 1 is going to be 1. There's only one way to get there. Now, starting from there, okay. So now we need to basically populate the memoization. And then at the end, we need to check, let's see, is there a 0 in here? No, there's not. Is there a 1? Yes, there's a 1, and a 2. And is there a 3? Yeah, okay. So I think that should do it. Great. All right, so here's the approach. We are going to look to see I guess I do need technically to keep the inverse list as well, so we may as well construct that real fast. Okay. There we go. If exists voltages I plus diff, then okay, that should do it. Yep, that should be fine. That has a bug in it. Where is this? Oh. If voltages wait, that's wrong. And that's fine. Where's my bug here? Oh, it's I minus minus, not plus plus. There we go. All right, I think that should do it. Let's just check. Let's just check the example. 16, 10, 15. Is that right? 16, 10, 15. Just going to check this because I don't want to incur the penalty. So this says that there are 8 arrangements. Why does it think that there are 8? Oh, because there's no there's a 1 in there. Okay, it's fine. Fine, we'll do it this way. this is just making this work nice and generically. There's no reason I technically have to do this. So exists v that should do it. Line 67, why is pos not used? Oh. Okay, yep, that returns 8 as we expect. The second one is more interesting. So the second one is a larger example. We'll put that in there. And that's 19208. Yep, so I'm actually confident that my answer here was actually correct. So I'm going to go ahead and plug this in. And that's correct, rank 286. Very nice. Okay. It turns out that apparently a lot of people who are doing Advent of Code this year do not know how to memoize. And a lot of the people who had been super fast and in the top 1,000 or 2,000 are struggling with the algorithms here. So why don't we go ahead and review what happened? That way, in case any of you who came in after me are wondering, like, how did you do that? This is the reason why I did so well in this one is because this is a variant of a interview question I really did ask software engineers at Google. And because it's a variant of an interview question I know very, very, very well. That's why I knew to do this trick. So let's go ahead and get it committed, so people can see what this looks like. So let's go ahead and check it in. Day 10 go. Day 10 AB solution. Okay. So we're going to go ahead and push it up to the cloud. So it'll be at github.com/LizTheGray. So here's what we did. Just to recap real fast. So part A was, again, something that, wait, actually I want to look here. There is no big skip, we just land at the island. Okay, that's predictable. So for part A, it's just, did you actually remember to sort the list? Which is straightforward, so I don't actually need highest now that I'm looking at this, actually. So let's go ahead and eliminate that. Right. So yeah, so here you're just asked to compute the difference between the previous and the next one, but where it gets interesting is down here. So if we remember that we always start at n+3, then you can think about the possible ways to get to n. N can go to n-1, n can go to n-2, and then n can go to n-3. But if we're going to flip that around, we can think about everything as instead, we can think about the potential candidates for where we could have come from as being n+1, 2, or 3 for our next value. So therefore, when you're computing the memoization, what you do is, we know that there's always going to be one way of doing this and one way of doing this, because that's kind of what comes out of the adapter, right? But then the thing that we can do from there is we can remember that, if there is an n-1 here, again, there's only going to be one possible way for it to go there. But for n-2, if it exists, right? Like, not all of these exist. There may be holes. You could potentially get there, right? This n-2 value is going to come from adding up ways of n-1 plus ways of n, which is, in this case, 2, if n-1 exists. So it's basically, whether you call it memoization or dynamic programming, what we're effectively doing is filling these in from the top on downwards using the values that we've previously computed. So, spoilers alert, I'm going to spoil a Google interview question that I don't think anyone asks anymore, but that I asked for about 5 years, which is, you know, this is essentially a 3D variant of the 2D puzzle that I asked. The 2D puzzle that I asked looks something like this. So let's suppose that you are at the star, and you're trying to get to the 0, and you can only move left or down at each step, and there are some holes in the graph that you can't step on. So if you can only move left and down at every given step, how many ways are there to get to the origin starting from here, right? And the interesting thing is, right, like, you know, you can always look right and up and add those two values together, right? You know there's one way to get here, and therefore one way to get here and one way to get here, but therefore there must be 2 ways to get here, and there must be 3 ways to get here. Oops, there's a hole, so that has to be, right, so 1, that's 3, this is 6, but then this here is also 6, right? Like, that kind of algorithmic thinking and filling in the puzzle with gaps, that's exactly what this problem is, except for instead of it being in 2 dimensions, it's in 3 dimensions, right? So instead of you being able to move left or down, you can move left, down, or in order to get towards the origin, and that's basically why I saw this so easily, because like this is just, instead of 2 directions to travel, it's 3 directions you can travel. But either way, right, like it is the traveling towards the origin with certain moves allowed, certain moves not allowed, and sometimes there's a hole that you can't step over. So that's basically what I saw here. So that's how I solved the puzzle. I'm going to go ahead and check this in, and I'm really disappointed that I checked my answer against all the inputs before I submitted. I probably could have turned up in the top 100, but that's okay. So, Eric, nice puzzle, well done. Appreciate it. Yeah. And then let me just fill in this one really quick. What is this? This is going to be ways of n minus 2 plus ways of n minus 1 plus ways of n. Okay. Yeah. All right. So let's go ahead and end the stream for today. I'll see you all tomorrow, and I'm going to go ahead and send things along to, let's send things along and see whether Epsilon is still running. Looks like Epsilon is running, so let's go ahead and rate Epsilon. Cheers, folks.